I'll check if you're paying attention. No, thank you, Alea. So if you said that the corn kernel will be white, you are right. So yeah, because I said that the DS is the dissociation or dissociating element is not messing with the white allele, then the white allele gets that gets expressed and the kernel is white. Okay, so we're going to get a little more complicated now, where you do have the AC element. So the AC is the activator. So I was thinking if this was the toddler that can't go anywhere, but this is the person, the parent, or whoever it is that can actually move this guy, then the activator can move the dissociator to near the white allele. All right, so in this case, the DS it can be transposed. You can think about it, this can jump to here. It doesn't get jumped, it gets carried. So some transposable elements, they can jump on their own. They're called autonomous. So it's like a toddler with a car. And some of them, they needed to be picked up by somebody else. They're non-autonomous. So in this case, this is the non-autonomous part, and it requires the presence of this other element. And it can jump to next to an allele, and where it lands, as far as I know, is random. Maybe people have found that there are hotspots for landing places in the genome, but that I learned of, it jumps and it lands somewhere. Okay, so and it goes somewhere else in the genome, and it causes a break point at the point of the insertion. So in this case, these two get broken. And now you're like, oh, what does that do to the expression? So there's a little bit more information even. Let me go up to here. So here you have the allele. This part upstream of the gene, so let's say that the gene is being read from left to right, so that's 5', 3'. The part upstream of the gene is the regulatory sequence. So remember, the gene is the part that gets transcribed. The regulatory sequence is where the promoter is. So the mid to far part of the promoter, that's where RNA polymerase and transcription factors bind to decide when this guy gets transcribed. And now let's say that the regulatory part is far away from this. So if the RNA polymerase binds over here, and now it's far away, just think about if this is the cell, you can imagine that this broke, and this is now somewhere else in the cell. It's not near this. Then what would be the color of this kernel? And the answer to that lies on the fact that the RNA polymerase is bound to the regulatory sequence, but it is not going to read the white allele.